Have you ever wondered what exactly happens during a nuclear meltdown? It's a question that many of us might have pondered at some point in our lives. After all, nuclear energy, with its immense potential and inherent risks, has always intrigued us. In the world of energy production, nuclear power is a titan, a force to be reckoned with. It harnesses the colossal energy stored within the nucleus of an atom, transforming it into electricity that powers our homes, our industries, and our cities. But with great power comes great responsibility. The same energy that lights up our world can also trigger catastrophic events if not properly managed. Events like nuclear meltdowns. Now, the term nuclear meltdown is as ominous as it sounds. It's a phrase that brings to mind images of disaster, destruction, and desolation. But what does it really mean? What happens when a nuclear reactor, a marvel of modern engineering, spirals out of control? To put it simply, a nuclear meltdown occurs when a severe failure of a nuclear power plant system prevents proper cooling of the reactor core, leading to the core overheating and melting. If this melted core breaches containment structures, it can release radioactive materials into the environment, causing widespread contamination and posing significant health risks. But how does a system designed with multiple safeguards and redundancies fail to such an extent? How can we prevent such a scenario? And what does the future hold for nuclear energy in light of these risks? These are questions that scientists, engineers, and policymakers grapple with every day. The answers are complex, entwined with the intricate science of nuclear fission, the engineering of nuclear reactors, and the policies that govern their operation. In this video, we'll delve into these questions, exploring the science and engineering behind nuclear meltdowns, understanding how they can be prevented, and looking at the future of nuclear energy. We'll take you on a journey into the heart of a nuclear reactor, shedding light on the enigma of nuclear meltdowns. So, are you ready to unravel the mysteries of nuclear energy? Stay tuned as we unravel the mystery of nuclear meltdowns. To understand nuclear meltdowns, we first need to grasp the basics of nuclear energy. Nuclear energy is produced through a process called nuclear fission. Picture this, if you will. Atoms, the building blocks of matter, are split into smaller parts in a controlled way. This splitting releases a colossal amount of energy, which is then converted into electricity. Imagine a game of pool. The cue ball, representing a neutron, strikes the 8-ball, which signifies our atom. The 8-ball splits, sending other balls, or in our case, more neutrons, careening around the table, striking and splitting other atoms. This causes a chain reaction, and it's this series of events that generates the massive energy we're talking about. This all happens within a nuclear reactor, a complex system designed to control these chain reactions. The reactor's heart is the core, housing the fuel rods filled with tiny pellets of uranium or plutonium, the elements that undergo fission. The core is submerged in water, which serves a dual purpose. It cools the core and acts as a radiation shield. Now you might be wondering, how does this lead to a meltdown? Well, if for any reason the cooling system fails, the core temperature can rise uncontrollably. The fuel rods can then melt, and if the situation escalates, they can breach the reactor vessel, releasing radioactive material. This is what we term as a nuclear meltdown. However, nuclear reactors are engineered with multiple safety systems to prevent such scenarios. For instance, control rods made of materials that absorb neutrons can be inserted into the core to slow or stop the chain reaction. But sometimes, despite best efforts, unforeseen circumstances can lead to a failure of these safety measures. Now that we know how nuclear energy works, let's delve into what happens when things go wrong. A nuclear meltdown is not just an explosion but a complex sequence of events. Imagine a well-orchestrated symphony where each instrument plays a vital role. In a similar manner, a nuclear meltdown is a catastrophic concerto of disastrous events. The key players in this symphony of destruction: the reactor core and the cooling system. Let's begin with the reactor core. This is the heart of the nuclear power plant, where the magic and the menace both reside. It's filled with fuel rods which contain uranium or plutonium atoms. When these atoms split, or undergo fission, they release a massive amount of energy. This energy is what we harness to generate electricity. However, this process also generates a lot of heat. If not adequately managed, this heat can become the harbinger of a meltdown. Enter the cooling system. Its job? To keep the reactor core at a safe temperature. It does this by circulating a coolant, usually water, around the reactor core. The heat from the fission process turns this coolant into steam, which is then used to turn turbines and generate electricity. The steam is then cooled down and returned to the reactor core, creating a continuous cycle. But what happens when this cooling system fails? The heat within the reactor core builds up. The fuel rods become so hot that they begin to melt, a condition known as a nuclear meltdown. This intense heat can breach the containment vessel, releasing radioactive material into the environment. This process is not instantaneous. It's a slow, creeping disaster that can take hours or even days to fully develop. And throughout this time, the heat, pressure, and radiation levels within the reactor continue to rise, creating an increasingly dangerous situation. The most famous examples of this are the Chernobyl disaster in 1986 and the Fukushima Daiichi nuclear disaster in 2011. In both cases, failures in the cooling system led to a nuclear meltdown, with devastating consequences for people and the environment. So that's the chilling sequence of a nuclear meltdown. But can we prevent it? Preventing a nuclear meltdown is not a matter of chance but of careful design and stringent safety measures. It's a statement that rings true in the ears of every nuclear scientist, engineer, and worker across the globe. And here's why. Let's take the first line of defense, the cooling systems. They are akin to the human body's circulatory system, regulating the temperature of the nuclear reactor. An overheated reactor is a ticking time bomb, and the cooling systems ensure that the heat is dissipated efficiently and effectively. These systems are often redundant, meaning there are multiple backup systems in place to step in should the primary system fail. This redundancy is a crucial aspect of preventing meltdowns. Next up, we have safety protocols. These are the rules and regulations, the do's and don'ts, if you will, that govern the operation of a nuclear power plant. They're like the traffic rules that keep chaos at bay on the roads. These protocols are put in place to ensure that every situation, even the most unlikely ones, are accounted for and have a predefined response. They are reviewed and updated regularly, keeping up with technological advancements and lessons learned from past incidents. And finally, we have regular inspections. Think of them as the regular health checkups you get at the doctor's. These inspections involve checking the integrity of the reactor, the efficiency of the cooling systems, and the adherence to safety protocols. They ensure that any potential issue is identified and rectified before it escalates into a serious problem. So, you see, preventing a nuclear meltdown is akin to maintaining a well-oiled machine. It involves a delicate balance of various factors, all working in unison towards a common goal: safety. And just like a well-oiled machine, a well-managed nuclear power plant can continue to safely provide us with the energy we need for our everyday lives. As we see, preventing a nuclear meltdown requires a multi-layered approach. With the looming threat of meltdowns, what does the future hold for nuclear energy? As we gaze into the horizon of the future, it's clear that nuclear energy will continue to play a significant role in the world's power supply. But it's also clear that the industry will have to evolve to meet the challenges of safety and public perception. The risks associated with nuclear energy are undeniable. The potential for meltdowns, as we've discussed, is a stark reminder of the dangers inherent in harnessing the power of the atom. But it's also important to remember the benefits. Nuclear energy is a reliable and efficient source of power that produces no greenhouse gases. It's a key player in the fight against climate change. So, how do we reconcile these risks and benefits? The answer lies in technology and innovation. There is a new generation of nuclear reactors on the horizon, designed with safety as a paramount concern. These include designs like small modular reactors, or SMRs, which are smaller, safer, and more flexible than traditional reactors. They can be built off-site and installed anywhere, reducing both construction costs and risks. Then there's the promise of fusion power. While still largely experimental, fusion could offer a virtually limitless and clean source of energy, with no risk of meltdowns. The challenges are significant, but the potential benefits are staggering. And let's not forget about the role of policy and regulation. Stricter safety standards, enhanced oversight, and a commitment to transparency are all necessary to ensure nuclear power's place in our energy future. Yes, the road ahead for nuclear energy is filled with challenges, but also with opportunities. It's a road that will demand our best efforts in science, engineering, and policy making, but it's a road worth traveling. Nuclear meltdowns, while daunting, are not inevitable. With careful planning and technological advancements, nuclear energy can remain a viable source of power.